Spectral inversion is a method for predicting layering and architecture from seismic data. There are a number of useful byproducts associated with such investigations. For example, you can use the 3D layering solution at the seismic grid scale as a reservoir model to investigate dynamic flow simulation. This can provide seismic-based insight regarding connectivity and paths of least resistance. To illustrate, let's look at an example from Schiehallion, a field that has a number of injector and producer wells. Here, we see a 3D surface extracted from the predicted layering solution. Now, let's look at a cross-section through a well location. On the left, we see a spectral layering solution. On the right is the input seismic data. And in the middle, we see a filtered reflectivity model based on the layering solution. Now, here on the upper left, you see a single slice from the predicted architecture. In this case, red is the reflective reservoir material and blue is the background. We can then simply use the layering solution as a reservoir model, put in the injector and producer locations, and turn on the streamlined flow simulator. This allowed us to characterize floodfront behavior from the perspective of the injectors, as shown in the top center, and drainage front behavior from the perspective of the producers, as shown in the upper right. Remember that what we are looking at here are 2D map views at one slice through a full 3D layering and flow solution. The flood fronts show the paths of least resistance from the injectors to the producers. So, where the contours are moving, in other words, where the blue color shows up, is where the pressure is building up from the injectors. The drainage fronts indicate what is happening from the perspective of the producer locations. If you compare the flood front picture from the purely seismic-based workflow to the results from the full field modeling that required substantially more manpower and time, you find that there is a pretty good match between the two approaches. The full field model showed no connectivity across the main faults. The pressured up zones are shown in red. These red high pressure zones correspond very nicely to the blue flood front zones. There is a nice match between the significantly more exhaustive full field model and the relatively quick spectral inversion-based exercise that takes you from seismic to layering to fluid flow simulation, indicating baffles, compartments, paths of least resistance, etc. This seismic-based approach does not take the place of rigorous multidisciplinary full field modeling, but it does provide a quick way to show what seismic brings to the table in terms of connectivity, baffles, seals, bottlenecks, and paths of least resistance. The spectral inversion-based layering solution can be investigated at the seismic grid scale with no upscaling to determine seismic-derived compartmentalization and dynamic connectivity.